Okay, let's continue our second way of solving the recursion. That is called a iteration way or iteration method. Well, for iteration method, and if you are experienced about solving recursion, and you may find doing this side by side way to solve a recursion is a lot of work to do because it's really a lot of writing. So instead of doing the substitution in the iteration approach, and then we don't do really the right side, but it requires you to be a little bit familiar with the solving recurrence process. Okay, so the general process will be you want to expand the recursion, and then you work on some algebra and to uh, uh, massage this expression, and then you evaluate, and then you continue the next level of the expansion. So let's see an example. Well, and for this example, we are using the Sn instead of Tn, but you don't have to worry about that. It is still a recursive definition of Sn. So if we want to expand a little bit, of course, we start from the original form, and then as you can see, the hard part is how do we do the Sn n minus 1. So we want to plug in the n minus 1 here and also n minus 1 here instead of n. So we expand that for one more level. So we expand the Sn minus 1 to this part. So c plus Sn minus 2. And then we massage that a little bit. So we have 2c plus n minus 2. So the next part will be how do we expand the n minus 2. So instead of n here, I want to do n minus 2, and here n minus 2 again. So now I have 3c plus Sn minus 3. So if we keep on doing this, then probably you will see the pattern. So you see c plus n minus 1. So 2c plus n minus 2. 3c plus n minus 3. So do you see the pattern? The pattern should be kc and then plus a Sn minus k and equals ck and plus Sn minus k. Okay, so after we expand that for a couple of the runs, and we will see the pattern. And when you see the pattern, you can stop, and then you can put the Sn into this way. Even though we introduce one extra parameter k, but this k we will figure out the k. Well, when do we stop again? So for each recursion, there's going to be a stop point. That's the base case. So in our base case, so S0 will be a 0. So how do we get 0? So 0 means so 0 means n minus k is a 0. This means k equals n, right? So when k equals n, and we just substitute this k and this k with n, so we got Cn plus S0, and S0 is 0. So Sn is a Cn. This is a approach that we can solve the recursion. And the thinking is similar, but we don't want to do the side by side because it just takes a lot of writing. And for some of the easy cases of the recursion, or your experience with solving recursion enough, and then you don't have to use a substitution to save you a little bit of the writing time. Okay, so now we have finished solving this one, and this is c plus Sn minus 1. So let's see the next part. The next part will be n plus Sn minus 1. So this constant c has been changed to n. So does that make any difference? So how about we use the same approach and we try to solve that? We start from Sn equals n plus Sn minus 1. Okay, and we want to solve the Sn minus 1. So this n, this n, this n, and this n, they will all be substituted by n minus 1, and then we will have this word. This Sn minus 1 will be substituted by this part, and again, I want to do some massage. Oh, well, this way I didn't do massage and just go on, and I just substitute the n Sn minus 2 with n minus 2 plus Sn minus 3. So, okay, I go on by one level and one more level, and And when you see the pattern, and the pattern will be, we go down n minus 1, n minus 2, and then we go down to n minus n minus k minus 1. And then we have s n minus k. Okay, so, well, and then we can put the sum from n to n minus k minus 1 together into this sigma, and this n minus k is the same. And the next part, again, we want to answer the question, then where do we stop? We stop at 0. So how do we get 0? We are going to get n minus k is 0. So in this case, well, this means when if k equals n, we are going to stop. So when n equals k, and then what is this sigma? So for this sigma, since k equals n, so we are adding from 1 to the n, and we add them together, and that is the sum, and plus s n minus k. But when n equals k, and then it will be s0, and s0 is 0. So in this case, Sn, we add everything together down to S0, and then we will have n multiplied by n plus 1, and then divided by 2. That's the sum from 1 to n. So again, we started from a recursive definition, and we want to break it down, and eventually we want to come here after we have observed a pattern. And after we observe the pattern, we answer the question, where do we stop? And then we plug in the right number of the k, and then we got this recursion solved. Okay, so let's see a slightly harder one. So for this one, you may find using the iteration way is not so handy, especially if you find you get lost in the middle. So for this question, if I were doing this by myself, and probably I will use the substitution way instead of iteration way. But anyhow, let's see how we can solve that in the iteration way. So we start from here, 2tn divided by 2n plus c. Okay, and then we do one level. So tn divided by 2, and then in the parentheses we break it. We do one substitution. So 2tn divided by 4 and plus ac, and this not so easy to read, but anyhow, let's do some massage, and then we got this one. And after that, I want to figure out what is n divided by 4, tn divided by 4, and then I got this part, and again I want to do some massage, and I got this. So as you can see, doing the iteration way in this case can really be annoying because you are doing a lot of the parentheses. But okay, let's move on. And after that, we do one more level, and we got 16 t and divided by 16 and plus 15c. Okay, so if you are doing all the manipulation of the equations correctly, and probably at this part you will see some of the pattern. So 2 powers 4, and then divided by 2 powers 4. And what is this 15? This is 2 powers 4, and then minus 1. Right? So, okay, now we can put this into using our observation to put that into a pattern. So that is 2 powers k and t and divided by 2 powers k and plus 2 powers k minus 1 and multiplied by c. Okay, so after we have this pattern figured out, and we want to ask the question again, how do we get to the 1? So when are we going to have the 1? And then we will end this, right? So this part, so tn divided by 2 to the k will be a 1, and this means what? This means k will be 2 log 2n. And then we replace this k, and this k with log 2n, and then we can solve this recursion, and eventually you will get n t1 and plus n minus 1 c. So t1 is what? T1 will be a c, so this one will be a constant. So a constant multiplied by n and plus n minus 1 multiplied by a constant. So eventually we will have this, and this is a polynomial version of the Tn. So we have seen 3 examples using the iteration way. I would say the first two problems, solving that with iteration is easy enough. You don't have to divide your working zone side by to 2 parts. But for the last question, this one, and I would say using the iteration to solve this one is a little bit hard because you are dealing with so many level of parentheses. Okay, so when you are solving recursions, and it's not really up to you on which one you want to use. And so far, we have learned two ways: the substitution and the iteration. So, well, this is the reading part. If you have watched my video and then you want to do further reading, and those are the sections you want to read. So we haven't really finished everything in section 2.3 yet. So you only have to do the reading of the 2.3.1, and section 3 is about big O, big theta, and big omega. So that's it for today, and thank you, and we'll see you next time. Bye.